All right, so as we get ready to get into some algebra here, we're going to start with looking at a lesson about variables and expressions. Now, let's start out by defining a variable. A variable is a symbol, usually a letter, that represents a value that can change. Usually those letters are X, M, T. Right? We'll take a look at some of those in an example as we get a little further into the lesson. Now, along with the variables, we have a constant. Now, a constant is a value that doesn't change. So now, as we work with variables and expressions, we're going to use a process called substitution. So let's take a look at an example here and get started. For instance, if we take the expression 2x plus 5, the x is our variable, the 2 and the 5 would be our constants. So the x is going to change depending on what we want to put in there. So let's say we have 2x plus 5 for x equals 4. Now we're going to use a process called substitution. So we're going to take this 4, which is our value of x, and we're going to substitute it back in for that variable. So if we were to rewrite this using our 4, it'd be 2 times 4 plus 5. And if we follow our order of operations, we do our multiplication first. 2 times 4 is 8. Add our 5, and we get a total of 13. So once again, our variable is represented by the letter. Our constants are the numbers that don't change. And we use substitution by putting back in this value for our variable to solve. Let's take a look at another example. Let's say we have m divided by 4. So in this example, we have a variable of m and a constant of 4, and our operation is division. So let's give a value for m. We'll say for m equals 24. So we're going to use substitution again. We're going to take the value of our variable, which happens to be 24, and substitute it back into the expression. So if I rewrite this, I have 24 divided by 4. 24 divided by 4 is 6. So once again, our variable, our constant, and we put the value for the variable back in. It's called substitution. One more example. Step it up here a little bit and use some exponents. Let's use y squared minus 3. Now, our variable is the y. To the second power, that is actually a constant because that won't change. And our 3 is a constant. So let's put a value on our y. Let's say for y equals 5. Now, through the process of substitution, we're going to take our 5, for y equals 5, and we're going to put it back in here for y. So if we write this, we have 5 squared minus 3. Using our order of operations, we do exponents first. So 5 times 5 is 25. 25 minus 3 is 22. So that's solving expressions when given a value for a variable through the process of substitution. Now, other ways you might see this is in a chart. So let's set up a chart, and this really shows where your variable can change and your constants don't. Alright, so let's do a variable of x, and let's do an expression of 3x plus 4. Now right now, I don't have any variables listed to substitute in, but I do have some constants. My 3 and my 4 are constant. Let's put some variables in here. Let's say 1, 2, 3, and 4. Now every time we change our variable, we're going to change our output. So let's start out by substituting our 1 in for our variable x. So 3 times 1 plus 4. 3 times 1 is 3, plus 4 is 7. So our output is a 7. And we just repeat that process. So now substitute our 2 in for the variable. 3 times 2 plus 4. Multiplication first. 6 plus 4 is 10, so our output is 10. Substitute our 3 in. 3 times 3 plus 4 gets us 13, so that's our output. And finally, we'll substitute our last variable in of a 4. 3 times 4 plus 4 gets us a total of 16, and that's our output. So what I wanted you to notice here is that we have variables that can change, and those are represented by a letter. We have constants that don't change, and those are represented by numerals. And then through the process of substitution, we can put a value in for our variable and get a different output every time.